In this session, we will continue with the topic which we were discussing in our previous video, that was about the introduction to the object-oriented databases and the basic features of object-oriented databases. So we were discussing about the features like object identity. So every object in object databases will be identified by using an object identifier, which is an immutable value, and we can represent the structure of an object by using various type constructors. So these 3 points were briefly described in our previous video. Now we will see one example where we will take some relations, that is the tables from the relational model, and we will have a comparison with the object-oriented databases or the object creation based on the relational model that is already available. So how we can represent the different objects and its features in the object-oriented concept, and the different notations used for representing all the elements. All these details will be discussed in this particular video. So we are taking an example which is already there in Elmastery database textbook. The one of the commonly used database schema, relational schema over there is a company schema, which is a common relation that is used in that textbook. So we will take a relation company. Now just look into this company relation. A company schema. Company schema consists of a number of relations, number of tables. So first table we are mentioning here is employee. You can see employee consists of first name, in a minute, that is the middle name, last name, then a social security number, it is just like an ID, similarly birth date, then address, then sets, salary, super SSN, that is the social security number of his supervisor, and the department number in which he is working. So you can see a number of employee names with its initials and last name, then their social security numbers, their birth dates, their address, set salary, and their supervisor social security number. You can see one of the employee, James, is not having a supervisor, so maybe he will be the authority, and these are the different department numbers in which they are working. So this is the normal relation table representation under the company schema, which consists of a number of tables. So employee is one among that. Then we will see some more relations. This is a relation which is called as department, where we are having department name, department number, the social security number of manager, that is manager, these departments manager's social security number, and his manager start date, from which date onwards he is acting as the manager. So this is the description of each department. So the departments like research, administration, and headquarters, and its corresponding department numbers, their manager social security number, and from which date he is the manager over there. We can see in this department table, D number is the primary key, that is why this underline is given there. And in the previous case, you can see the social security number is the primary key that is used to identify uniquely this table, where we have given underline. So normal relational data model representation, the primary key attribute is separately given and underlined to identify that. Now similarly, look into another table, department locations, that is another relation where we are maintaining all the locations of departments. For it consists of 2 attributes, department number and department location. Each department number 145 So department number 1 is located in Houston, department number 4 is at Stafford, 5 is at Bel Air, 5 is also there in Sugarland, 5 is also there in Houston. So we are having for the department number 5 we can have different locations. So in this table, department number and delocation together are considered as primary key, because department number is repeating here, so we cannot identify by using that. So that is why we are combining these two to form a primary key there. So it is only a review, because already you are familiar with normal relational database representations, right? Now similarly you can see another relation which is called as project, where we are having project name, project number, project location and department number. So different projects are there, and they have given some names, and these are the different locations where the projects is being carried on, and these are the departments in which these projects are under the work. So here the primary key is project number. Now similarly you can see one more relation. So we have taken only some sample relations only. Work zone represents the details of the different employees who is working on different projects, and it deals with the number of hours the employee is working on different projects. So you can see it consists of employee social security number and his project number and number of hours he is working. So one employee, first employee is working at project number 1 for 32.5 hours. Similarly, another employee is working on project number 2 for 7.5 hours. And here you can see this employee, he is working on two different projects, with one project 30 hours and second project 10 hours. Similarly, you can see some of the employees are working on more than one projects. So that description is given in this work zone table. Similarly, you can see one more table that is called as dependent, that maintains the details of the employees dependent information. So the company employees, they are having some informations regarding their dependent. So for this particular employee, he is having a dependent called as Alice, who is a female and whose birth date and the relationship is daughter. Similarly, the same employee is having another dependent who is the son. Then again he is having another dependent, he is the spouse. So sorry, she is the spouse. And similarly for other employees also, they have given their dependent details on a dependent table. So here the primary key is maintained by combining employee social security number and the name of the dependent, because you can see the same employee is repeated in different number of rows. So we cannot identify this entire table by using ESSN alone, so we need to use dependent name also. So in the previous, here in the work zone table, you can see the primary key is again combined by employee social security number and project number to form the primary key of this particular table. Now this is the situation where we are using a company schema where employee relation is maintained separately, a department location is maintained separately. Similarly, department, work zone, project, dependent, etc. All these different informations are stored separately in different relations, but these relations are connected by using some of the attributes, especially by using primary key and all. So here employee, different details are there. Now here department, you can see it is connected through this social security number with the employee table. Similarly, this department number with department table, it is assigned its department. Similarly, in department location, it is referred by department number, which is already there in department table. Now work zone consists of employee social security number, which is depending on employee table, project number, which is depending on project table, So similarly in dependent, you can see employee social security number is depending on employee table. Then similarly all these relations are related each other, and they, whenever if you want to get some information from these entire company schema, we need to have some connection between these relations, and based on those connections only we can get the entire details of a particular employee or a dependent or anything, or about a particular project or about the department, etc. Now the situation will be changed in the case of object-oriented databases. So let us see how this will be represented in object-oriented database concepts. So we were discussing about object identity, then the structure using various type constructors. All these were already discussed in the previous video. Now we will use an example notation for representing these objects in object-oriented concept. So here we will use different ID numbers like I1, I2, I3 up to n numbers for representing different object identifiers. It is only a number for explanation, but system will be automatically generating these numbers internally. So we don't know what is actually the format of this ID, but that is unique of course. So we are simply using I1, I2, I3 for representing these IDs. So now we will see the different object notations here. Now object 1, so listen this carefully. Object 1 is equal to, so how we are going to represent object 1? It will be given a name I1, ID is assigned I1, its comma, its type constructor is atom. Atom means it will be a single value, and the value assigned is Houston. So object O1 is actually representing the value Houston, which is an atomic value, and this object is given the name O1. Internally it will be identified by I1. So system will be identifying this object by using I1. Similarly you can see O2 is another, these are only some examples. Similarly O2, another I2 identifier, then it is also an atom, and another location belayer is given. So belayer is an object of using type constructor atom, and which is internally given the name I2, which is the object 2. Then object 3 here is given I3, which is also an atom, it's a single value, Sugarland, that is given into the object number 3. Now object number 4, again I4, it is also an atom, but the number given is 5. Maybe we can represent a department number 5. So 5, that single value itself is an object which is an of type atom, atomic or atom, given the identifier I4. Now object 5 is given I5, which is also an atom, research, which is the department. So every individual values present in the relation will be considered in object database in the form of different objects with an object identifier. Now O6, I6, it is also an atom, a date of birth single value is given, so that is also considered as an object. Similarly O7, it is given an object ID I7, and which is using a type constructor set. So what do you mean by set? Set is a group of values without repetition or with distinct values. So what are the values here in this set? In set you can represent the values in these curly brackets. Within these curly brackets a set of values can be given. So what is this I7? Object 7 is identified by using I7, and it is of type set, which is having a set of 3 values. What are these 3 values? One value is I1. What is I1? I1 is Houston, I2 is Blair, and I3 is Sugarland. So what is this I7 or object 7 represents? An object with a group of values, that is, it is a set of atomic values, a set of objects, a set of I1, I2 and I3 forms the object number 7 by using the object identifier I7. So this is the way in which we are representing the different objects. Similarly, we can continue object 8. Object 8. Let's see what are the features of that. It is given an object identifier I8. Now we have taken another type constructor which is called as tuple. So object 8 is given identifier I8, which is a tuple type, means it is further divided into a tuple. It is having further division. So its division can be represented in between these angle brackets. So first one, department name colon I5. So it is again having another tuple with one attribute, that is department name colon I5. Department name I5. So what was I5 there? I5 was research. So department research represent here. Department name research. Department number is I4. What was I4? Department number I4 was 5. So that 5 will be here. Then manager colon I9. I9 is given here in the next state. So there this details about manager, which is again further a tuple. So object 8 is an object which is further a tuple. So that means its structure is little more complex with further number of attributes and its corresponding identifier. So by using some other object, this tuple will be formed. Okay, so for example, similarly here I can replace with name, first name. Then you can refer to an identifier where first name is given. Then middle name, I can give an identifier where the middle name is already represented in object format. Then last name colon, I can provide the identifier where the last name is given as an object in the previous notation. Similarly, locations represent I7. Locations, we know more than one location. So what was I7 here? It is set of I1, I2, I3. So here that will be added into this area. Then employees colon I10. I10, that is set to H-plane I10, which is again set of I12, I13, 14. So all the details are represented here. 12, 13, 14 all explains the details of employees. Similarly, projects I11. 11, it is again a set of projects. Okay, so this is the way how we are representing. So tuple, so we have seen atom, we have seen set, and we have seen tuple. So similarly, other things can also be used. So O9 is I9 with tuple manager I12. I12 will be having some features. Then manager start date, that is I6. I6, what is I6 here? Which is a date, which is already mentioned, which is already represented. So whatever objects are creating by using object-oriented databases will be stored inside internally by using the object ID, which is created automatically by the system, and by using that the remaining objects will be identified. So we'll be so this is only the representation, means how we can identify this. But for specific object-oriented databases, we need to use specific syntaxes for creating all these object structure and the object creation, that will use different formats. Now similarly, O10 set of different objects. O11 is also set of different objects. O12 is object 12 is again tuple of first name, initial, last name, social security number, etc., salary, supervisor, etc., etc. So a numerous number of objects are available, and these objects can be related to different objects by using different type constructor. So you can see this is an atomic object. This is following the type constructor set. This is following type constructor tuple. This is following type constructor tuple. It is following set. It is following set. Similarly, this is following tuple. So by using these different structures, we are forming the object structure. Now we are forming the object. So each object will be having its own structure. So some of the objects are very small objects. Some of the objects are complex with more means tuple structure with more number of objects included in further means by adding more tuples into the existing object. So some more explanation. I'll just read it out. The first 6 objects listed in this example represent atomic values that I have already explained. Object 7 is a set value that represents set of locations for department 5. The set refers 3 values: Houston, Bel Air and Sugarland, that I have already explained. Then object 8 is a tuple valued object that represents department 5 itself, that has attributes like department name, department number, manager, locations and so on. So these are the representations, some basic representations. So now you can understand what is an object, what is an object, what is an object ID, what is a type constructor, what is a value. I hope it is clear. Now we'll see one more example, a simple example to give 2 more definitions related to these object notations. So the following example illustrates the difference between 2 definitions for comparing object states for equality. So how we can say that 2 objects are equal? So object 1 I1, which follows tuple A1 colon I4 A2 colon I6. So it's exactly similar like the previous notation. Then object 2 I2 comma tuple A1 I5 A2 I6. So here a random attribute is given. Okay. Object 3 I3 tuple A1 I4 A2 I4. Now O4 is I4 atom 10, O5 I5 atom 10, O6 I6 atom 20. So you can see the same 10 is given in 2 different situations by using 2 different object identifier. So these are actually 2 different items. So that is why we are going to differentiate between these object states. So just listen here. The objects O1 and O2 have equal states. Just listen to this. O1 and O2 have equal states. Let us see. O1 A1 I4 A2 I6. O2 A1 I5 A2 I6. So I6, these 2 are okay, but this I4 and I5 are different here, right? What is I4? I4 is 10. I5, it is also 10. So these 2 are having same value. These 2 I6 I6. So both are having 20. So these 2 are having equal states because their states at the atomic level are the same. So they are having the same value. So we can simply say that they are having equal states, but the values are reached through 2 different objects, O4 and O5, right? O4, the 10 received through 2 different objects. So we cannot say that O1 and O2 are same, but we can simply say that O1 and O2 is having 2 different objects are having same states only. They are not exactly same, they are having same states or equal states available. So that is one definition. Now second one is the states of objects O1 and O3. Let's look at O1 and O3. O1 A1 I4 A2 I6. O3 A1 I4 A2 I6. So all the values are same, I4 I4 I6 I6. So 2 objects are now defined as identical. They are having they are identical because because they are having two objects are identical because they are following the same object ID for getting the tuple value for these two objects O1 and O3. So two objects are identical because they are following the same tuple structure. That is a simple definition. Even though the objects themselves are not, but the objects are not identical because they are using different IDs. So we cannot say that this O1 and O3 are identical. We can say O1 and O3 are identical, but we cannot say that O1 and O3 are same because they are having two different IDs. So they are not same, they are different. Objects are different, but objects are identical. O1 and O2, they are having equal states. Similarly, the states of O4 and O5 are identical. Similarly, O4 and O5 are also identical. They are also having exactly same value. We can call them as identical. But objects are not identical because they are having different object identifier. They are forming different objects with different object identifier. So just have a comparison between these equal states, identical, non-identical objects, identical states, equal states, etc. It is simply based on the object ID, the values associated with the tuple, the similarity of data or value, and identical in the tuple that they are using for both objects. So just for comparing equal states and identical states and object comparison, whether they are equal or identical. So just for representing this, we have given the example number 2. So anything may happen when we develop some objects inside an object-oriented database system. Now we will see how this structure will be formed. So in a pictorial, so just like as you know, in an ER model we can represent the entity relationship model by using different notations. In table we can represent by using rows and columns. Similarly, these can be represented by using different notations. So the basic three notations that we are using is small oval is used for representing an object, and this long one is used for representing a tuple, and this rectangle is used for representing a set. So how we will be developing this structure? So it is only a part of the previous relation is shown. It will be extended into a number of different stages. You will understand. This object 8, O8, a symbol object is represented inside this oval O8. Yes, we will have a look into the previous example. What was O8? O8 is a tuple with department name, department number, manager, locations, employees, projects. Okay, so let us see. Now O8, it's so this is the object structure, how we can represent. So we have to use these notations. So object 8, its object ID is I8, its type constructor is tuple, then we have to put an arrow, then it is a tuple type. So tuple can be represented by using this long what you say, it's like an oval. So what are its contents? Department name, department number, manager, locations, employee, and projects. Now we will see what is department name there. What is department name there? Department name is I5. Okay, department name is I5 colon. What is I5 there? I5 there is, which is an atomic value, that is research. So I5 is an atom. So O5, object 5 is I5, which is an atom, and put an arrow which is research here. So that ends here. There is no further connection. Similarly, department number, object 4 I4, which is also atom, value is 5. manager, which is also an object O9, which is of tuple type, which is further divided into a tuple with manager and manager start date. Now manager is again divided into I12, that is of O12, which is of tuple type with first name, init, last name, etc., etc. up to department. Now similarly, manager start date is again an object with atomic value and the date is given here. So this part is over. Then locations, I7, which is set. So this is a set representation, rectangle. Set one part is I1, O1, that is atom, which is Houston. Then O2, I2, which is atom, Bel Air. Then O3, I3 atom, that is Sugarland. So this portion is also over. Then employees refer to object 10, which is having identifier I10, which is again a set. Then set is represented here. Set first part is its employees first name, init, last name, department, etc. Then I13, which is again a tuple, which is further divided. Tuple 14, that is also divided. So this portion is not given because this is the way how we are expanding the structure of an object. Starting from O8, the structure is being expanded. So every element is having an object identifier that uses a particular type constructor. Based on the type constructor, its elements will be created and expanded. Now we can see projects O11, which is of set, which is again a set. We are having different divisions. Tuple again, all these again to be divided into further number of different tuples, each tuples with its attribute and corresponding object identifier. So that is to be expanded. So you should study the notations, the object notation by using this symbol, tuple by using this symbol, and set by using this symbol. And you need to describe some objects by using object ID, some type constructor atom value or some tuple value. Accordingly you have to create this structure. So starting from an object, if it is a tuple, form this tuple, and with this tuple each element that is to be connected to some atomic value or some set value. So you can simply represent one object with tuple, and you can have some 3 elements on that tuple. One element can be atomic value, another element can be another tuple, and third element can be a set. In that way you can simply represent an object structure for explanation purpose. So just understand these symbols, then object notations, object identifier, type constructor, and this V is used for representing the values that ends at atomic values. That is why we are giving different value numbers. Different values are given just for representing or identifying it as different values. Now let us see the basic way in which we need to create an object structure. So this was the pictorial representation. Now how we can create this structure in a language format for an object databases. So if you are familiar with the creation of classes in C++ or Java, in the same way we can create the structure for an object in object-oriented database also. So this is not the exact syntax followed in a language. It is only a generalization for the object types, the creation of object types, and how we can use the type constructors. It is only a general format. Later in the same module we will specifically select object-oriented language, and we will see the syntax of how we can represent the creation of these types by using its exact syntaxes. So here you can see define type, define space type employee. So we are going to define employee. So it is exactly the repetition of the previous relations. Now employee is of type tuple. So just write define type employee. It is the class name. Define type employee. Then its type constructor we have to specify here. Now it is a tuple, then open a bracket, then f name colon, which is an atomic value, so just provide the data type of that, string semicolon. It is just like a class representation. Similarly, minit, which is a char, last name string, SSN also string, birth date, which is using a date, a capital date, which is another type. So employee is a type. Now birth date is having a type. It is just like referring to another class. So we have to define this date separately. It is already defined here. We'll see that. Now address of type string, sets is of type char, salary with float, then supervisor is of another type employee, department is of another type department. So you have to define employee separately, then you have to define department separately. So you can see that a new type employee is being created, which is of following type constructor tuple, which uses some of the built-in types and some of the user-defined types. Built-in types are string char, this string char, float, etc. This date, employee, department, all these are user-defined types. So these fields are depending on user-defined types. User-defined types are represented in capital letters only in object-oriented databases. So this portion is over. So here after this, just put a bracket here and put a semicolon. Then I am going to define this type separately. Define type date, which is again a tuple, open bracket, year integer, month integer, day integer, close bracket, semicolon. So this type is also defined. So if this type is already there, now this birth date can refer to that particular type. Now department, define type department, which is also a tuple, a department name string, department number integer, manager, which is again a tuple, open bracket, the same format we are following, manager colon, then a user defined type, start date, date, another user defined type, then close bracket, semicolon. So one element within this department is again a further one more tuple. It is following a tuple type constructor. Then locations, it is following a set of string, locations, set of string. Employees, so set of what we are using is set of built-in type. So three string values will be available here. Employees is set of employees, set of user defined type employee. So we need to use some employee objects here. Set of employee 1, employee 2, employee 3, for example, that who follows the characteristics of this employee, that is to be defined separately. That is not mentioned here. Similarly, projects, set of project. So project to be defined separately. From there, its objects are part of like project 1, project 2, project 3. That is part of this set. Then close the bracket and put a semicolon. So this is the way how we are creating different types, or object structures are created. So object structure in pictorial format we have seen. Now this is the general representation of creating a user defined type. It is just like you can have a comparison with the creation of a class in C++ or Java, but here the difference is in we are only mentioning these types, the built-in type and user defined type. We are not mentioning any operations here. Functions are not mentioned here, but some basic elements are already given. But about function and operations we will see in our future slides. So this is the way how. So all these, so for explanation for this type construction, user defined type, you have to follow this syntax: define type, type name, then tuple, then write all this with the attribute colon, then put the type semicolon. If the type is a user-defined type, write it in capital, then put a semicolon. Then towards the end, put a bracket and put a semicolon. Then if you want to define, so any number of types can be defined in this format. So normally for a huge schema like company schema, you need to create a number of type like this, and within each type you will be having some connection with some other type. So here in employee we are having date, employee, department. So employee is connected with date, employee and department itself. So supervisor itself is an employee, that is why he is having a self reference to the same type, and he is having a department which is pointing to this department table. Now similarly, department is connected with employee, it is connected with the date, it is connected with again employee, it is connected with projects, which is again another type. So this is the way how we are creating the structure in object-oriented databases. So that is all about the basic ideas regarding the object notation representation and the general format of representation of objects and types that are used with object-oriented databases by using the pictorial notation as well as by using a generalized notation for the creation of different user-defined types. So in the next sessions we will be discussing more features about object-oriented databases and the different properties related to the object orientations that are applied to the databases. Thank you.